You might come back and make sure it's working good at some point. Okay, we're going to be graphing inverse trigs. Which is pretty much like graphing normal trig, it's just going to be flipped on its side. So the phase shifts are all going to be 0, so you don't really need to mention it. So what would be the amplitude for a secant? Anybody tell me? Undefined, good. What's the period of the secant curve? 360. And then the increments would be 360 divided by 4? So we go 0, 90, 180, 270, and 360. And then our asymptotes are where? Where are the asymptotes on a secant curve? No, not beginning, middle, and end.
The quarters.
The quarters. Because what's the secant curve look like? Anybody remember what I say it looks like? Window curtains. Okay, so it looks like window curtains. So it's going to start at 1, because that's what the coefficient is there. It goes to the asymptote, comes back to 1, and then in the middle, it's going to be going down at the parabola, letting the water out. Okay, you guys remember the secant curve. Basically, all you're going to have to graph is the main 3 trigs, sine, cosine, and tangent. So that's why we're practicing the ones that aren't, because I don't want to do your problems. Now to graph the inverse trig. I'm not going to reinvent the wheel. You don't need to write this down again. It's the same. But the inverse trig puts the graph, it changes your axis. So the x-axis is now the numbers, and the y-axis is going to be the degrees. Does everybody understand what I did? Basically, if you turn your head sideways, you can see that graph shifted. Okay, now where were the asymptotes again on the secant curve?
Quarters.
At the quarters. Now we start, and we started it at 1, right? And 1 is here, and we go to the asymptote. In between, you're at a -1 letting the water out, only now you aren't letting the water, it's to the left. And here you're going to end at 1, and it's coming from the asymptote. So can you kind of turn your head sideways and kind of see it? Well, let's do another one. Let's do the cotangent curve. So y equals cotangent of x. What's the amplitude? Zach, what's the amplitude and period on cotangent?
Undefined.
And what's the period?
360. 180.
180, yes. And the increments would be divided by 2 because it's the oddball, right? 9. Okay, so Delaney, where's the asymptote on the cotangent?
In the middle.
That's tangent. Where's it on the cotangent?
Oh, at the beginning and end.
Beginning and end. So test, remember, is going to be Tuesday, so that's one thing you're going to need to know is your graphs. Now, what's the cotangent curve look like now? Doesn't it cross at 0? Starts high, goes low, looks like a snake? Okay, now we want to make the inverse of it. What's different about the inverse? It's on its side. So I need 90 and 180. The asymptotes are still at the beginning and the end. And what's the cotangent curve do? 0, starting positive, then goes negative? Okay, so you understand what you're doing on the first three problems? You're gonna be graphing the sine, the cosine, the tangent, and its inverse. So basically you got 6 graphs to do. But the inverse graph should be a quick one, right? Because you don't have to re-identify amplitude or period or your increments because they're just gonna be the same. Okay, now, the rest of the worksheet is reviewing what we did yesterday. Is everybody got a calculator out? Oh, let's say I want the arc sine of 3/4. Notice it's not a capital letter. Mason, did you have a question?
No.
You're okay?
Yeah.
Now, what's different with capital letters and lowercase letters? Let's review that a little.
If it's capital, you find the principal.
Right, if it's a capital letter, you have to deal with the principal. So Terry, you might want to write this down for the principal. If it's a capital letter, then you're only looking for the positive to be in the first quadrant for all 3 of them. And then, of course, their inverses would be the same. I guess I should have made those capital letters. And the negative, the sine's 4th quadrant, cosine's 2nd quadrant, and tangent's 4th quadrant. Okay, but this one's not a capital letter, it's a lowercase letter. So we need to go to our calculators to find the reference angle. So what's the reference angle for 3/4? Has everybody found it yet?
The degrees minute seconds. 48 degrees, 35 minutes.
Anybody else, 48, 35?
Yeah.
Yeah, does everybody remember how to enter that in your calculator? You go second sine of 3 divided by 4, and then degrees, minutes, seconds. We also had another sheet that you don't want to lose this when you're going to be using the rest of trig. Okay, now, this is a positive 3/4. So where is the sign positive?
First and second.
First and second. So I need to place this angle in the first and in the second. To place it in the first, I don't have to do anything. It's just going to be itself, 48, 35. To place it in the second, what do I need to do?
Add 180.
Not add,
So
subtract, because you want it to be in the second. If I want it to be in the third, you add 180. So it's going to be 180 minus 48, 35. So I borrow a degree, which that's 60 minutes. 131.25. Okay. Let's do another one. You don't need to write all these down, but I at least get 2 of them. This time I'm going to use, you guys like the negative ones better. I don't want a capital letter yet, sorry. Okay, you don't put the negative in your calculator. Remember, that's your job to place it in the quadrants. So the negative you don't need, so it's going to be second cosine of 5/6 in the calculator. Degrees, minutes, seconds will get you your reference angle. So it's
33 degrees and 33 minutes.
33, 33?
Yeah.
Well, that's unusual. Everybody agree 33, 33? Now, where is the cosine negative at? Cosine is positive in the first and fourth, right? So it means it's negative in the second and the third. So to place it in the second, what do we gotta do?
Or add
You're right first time, subtract from 180, right? If you place it in thirds when you add it to 180. So we borrow a degree, I borrow 60. Get 146.27. Place it in the third, I add 33. And I've got my 2 answers. Okay, now, you don't need to write this one down. This is just another practice. Hopefully so Terry gets it. Now let's do tangent of Zero's not gonna be in your calculator, right? Well, zero would undefined, wouldn't. But if it's on an axis, you don't place it in a quadrant. You want this, right? So you turn to that back page. Where is the tangent zero at? There are two places, right? Because we're less than 360, 0 and 180. If it lands on an axis, you don't place it in a quadrant. You just write down where it occurs. And you can get that straight off of that chart. Okay, is everybody good there? Another one still. I want to make use of the chart again. Let's say I've got the cosecant of undefined. Which we could get that on the chart, but normally you wouldn't have cosecant, because we'd change it to sine, wouldn't it?
Sine of 0.
So sine of 0, and if you look on your chart, you'd say where's sine 0, because that's on an axis. 0 and two places. 180. 0 and 180. So you can find that directly on that chart. Now if you go down to the cosecant, since I do happen to have that on there, where's it undefined? 0 and 180. See, I could have got it there too. 360, but we aren't including 360 because we're making it less than 360, okay? So it's 0 degrees through 360 not including. Now let's go to the principal values. Now that's capital letter. So you don't put your negative in your calculator, so what's the reference angle for 1/2? What do you get?
Just 30 degrees.
30 degrees, comes out nice. But since this is negative and this is a principal, you take where sine is negative, which is only the fourth quadrant. So to place an angle in the fourth quadrant, what do I need to do? 360 minus 30. Cotangent of -5. Well, cotangent's not on your calculator, so what do I have to do to it? Make it tangent. So it inverts the 5 to 1/5. So now you go to your calculator. What's second tangent of 1 divided by 5 degrees minutes seconds? And again, you don't put the negative in your calculator. That's for you to do. So what's my reference angle?
11 degrees and 8 or 19 minutes.
11/19?
Yeah.
Now, this is where tangent is negative. So tangent is negative in what quadrant? Fourth. So to place it in the fourth, 360 minus it. So I borrow a degree. So I get 348.41. Everybody agreeable with that value? Okay, you guys okay on the principles? It's essentially the same thing, it's just not as much work, because you only have to place it in either positive quadrant or the negative quadrant. Now, what was the other thing we did yesterday? Does everybody want to refresh us? The specific trig, right?
Isn't it?
What do I have to do, Mason?
You have to find do the cosine of the 1/5 first.
Right, so you set up your triangle based upon the definition of the trig. So what's the definition of cosine?
It's adjacent over hypotenuse.
Good. So 1 and 5. So Pythagorean's theorem. And square rooting, that's 4 times 6, so it'd be 2 square roots of 6. Is everybody okay with completing the triangle? Now, what are you asked to find from this triangle? What's the size? Opposite over hypotenuse. And this was a positive, so I really didn't have to do anything because it's first quadrant, right? If it's positive, whatever you get is going to be your answer is going to be positive, let's do tangent of the inverse sine of 4/5. Make that negative. So what's sine by definition? Opposite over hypotenuse. So a squared plus b squared equals c squared, or you may remember from your geometry, the 3, 4, 5 triangle. And what quadrant are we in, since this is a negative and it's a principal value? We're in the fourth. So remember, this is coming from the fourth quadrant. Now, what's the tangent of that triangle? Tangent is, so it'd be 4 over, and is it gonna be positive or negative? Because what's tangent in the fourth quadrant? Negative, right? All students take calculus, so cosine would be the only one that'd be positive. That and its reciprocal. Okay, do we follow our specific trigs? Do you guys want another example? Are we good? Okay, so, worksheets. So you might want to check the camera. I kind of broke them into sections so you can see what you're doing on each one.